We've clapped. I'm Timmy.
I'm Justin.
I'm Nathan.
And this is Three Old Tech Dudes.
I did not see that coming.
What you got there?
I was going to joust.
Quite a rod.
Is that a... That's quite a lightning rod you got there.
Does your video contain controversial content? Yes or no?
You're going to poke a hole in your new ceiling.
Well, let's do this.
Jesus won't love you anymore. All right.
You're making baby Jesus cry.
This isn't going to help the people who go, oh, you do sit and laugh in your videos.
We're in the basement of the church.
We do
in case
that,
you
though.
didn't know.
We like having fun. I don't know what you're looking for.
I mean,
There's plenty of
Professionalism.
plenty of cross-eyed ham guys
Dude,
making videos on YouTube. Don't
I have to be professional.
You're
So
going to
what
poke a
you
lot
gotta do with this J-Po? That's what it's called. You gotta say it like a Southern Indiana guy. Po.
Poe?
It's a J-Po.
All right.
It's a
So,
You're going to put it on his tar.
It's a J. It's a pole, not a pole.
God,
And it's a tower, not a tar.
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 It's a tar.
I always love that.
Well, where'd this come from? Where'd this originate from?
Yeah, where'd you
So,
buy this?
no, well, yeah, sort of. I bought the parts. So this is a J-pole antenna. This is a 2-meter vertical, even though it's horizontal right now. But basically, this is a simple antenna you can build at home for 2-meter ham radio.
You could work too if you
And
had a
other
soldering iron.
You could.
Well, true. But so at our Hamfest, we had several classes this time.
We did.
And we did put some. And I actually put a class on how to build some simple antennas. And this was one of them. We had a couple others as well. And yeah, so we're going to show that now.
Nathan doing his thing. Here we go. Just want to let you guys know before we jump into this clip, the audio's a little rough. Came from our Hamfest this past year in October. This is an older clip that we're releasing now. Just not getting it edited. So bear with the audio. It's not real great. It's kind of an overview on antennas you can build at home, not so much how to build them. So don't want anybody come with any confusion. So if you'd like to see some of these antennas built that we haven't built, which is most of them here, let us know. Maybe we can put together a build video. We did build the G5RV he mentions. You can see that video right here. Check that out. It's actually one of our more popular ones on the channel. So enjoy.
So today I'm going to do a quick presentation on cheap antennas you can build at home. This is not one, in case you're curious. This thing probably cost the radio club that built this somewhere in the multi-billion-dollar range. Not a good one. However, it is gigantic, and it's a full 160 beam, which is just wow. Also, you can't see it in this picture, but there on that antenna, there's a guy inside it. How big that thing is. It's ridiculous. Okay, so when you're building your antennas, you're going to do with a little bit of math. Probably not quite that much though, but don't be afraid of it. It's not that hard. Honestly, it's just a mic. There's only a few equations you really need to know, especially if you're building something like a dipole. You don't need calculus, first of all. So, I think I threw this thing together when I was like 9 at night, so hopefully I got everything right. A few basic things to remember about your antenna. One, height matters, but if you're going to build like a dipole, for example, it does not require an extensive amount of really work to make the thing actually function. I've got a few examples of ones here. It really just takes some wire, some insulator, which could be something as simple as PVC pipe that you can buy at Lowe's. You drill. You should solder it if you can, if you're not afraid of soldering, just to make the connection solid. You can do it with very few tools. I mean, honestly, you need like a wire cutter. You probably need a soldering iron, a few small pieces. You do not need to know calculus. You really just need to know a couple of numbers. 468 is the big one, and then the division of that, 234, is the bulk of what you actually need to know, which is the length of the antenna designed for what frequency you're doing it in, so it's really not too bad. And honestly, you can also Google this. You just need a measuring tape to measure it out. You really should solder if you can, because the soldering process does two basic things. One, it makes an electrical connection, and it makes it physically connected, so it's bonded together like welding. Those are the two critical things that you do need to do. That solder does work better than crimping, but you can use crimping if it's just going to be like for a weekend. That'll work. But for soldering, there's a few basic things to remember. One, if it smells like dinner, you're holding it wrong. Solder is not food. And your soldering iron will start a fire. And I swear to God, it actually says this on this one. Do not insert that in any orifice. And the sad thing is, yes, people have actually done all of this, which makes you really worry about people. Okay, so back to actually something more usable. So on the 20-meter dipole, which is very common. So if you really, actually, hilariously, if you're building one for 10 meters, it's exactly half this size. Which is great, because if you're just a tech, for example, and you have access to the 10-meter amateur radio band at the 28.3 to 28.5 megahertz, it's exactly half the size of a 20-meter antenna, so 10-meter antennas. So when you're figuring it up, the half wavelength, which is the complete end-to-end, is that 468 divided by frequency in feet, which is very easy to calculate. Just you can grab your portable calculator / phone / internet device / everything else, and calculate that right up. And it's very, very simple. And obviously, you can Google the exact same thing and get the exact same number. This is for center fed. If it's offset, it's a little more complicated. But again, Google's your friend. It will tell you exactly how to do it, and you can find all that stuff. So when you're building an antenna, you basically have the wire. You'll have the coax feed line. You'll need an insulator here, which can literally be PVC pipe, or you can use, where did I put it there? I brought some things to show. It's showing antenna.
Visual aid.
Or you can buy actual insulators. This one came off an antenna that I was using. I'm pretty sure at least a few of the people around here have these. These are called dog bone insulators. So you're going to put one here with rope going out to whatever. Same thing there. And then the center, you typically have the one up here, you'll solder on your coax one side going one way, so you have the center conductor going one way, ground on the other. And you usually have something in here to attach this to a pipe, a pole, your house, whatever, just so it doesn't sag. And then coax coming down, and that's really about it. A lot of times, you can actually use this end here, can literally be a PL259, which is your connector, like that. And then you can use a coupler and then screw the coax on. So it's actually really, really quick. If you want to make this for like just a weekend for your like our contest or something, easy build. And they work extremely well. Now, if you're going to build antennas, any modern radio, as long as you get this cut with the length that it's supposed to be, any modern radio, I brought my modern radio with me, which of course then I covered up with a bunch of junk because Hamfest. So, yeah, I need a prop holder. So this radio, which I didn't spend $900 for, I told my wife. This radio has a tuner built in. So if this antenna is not exactly right, so the SWR is 1:1, which is a ratio. So you want effectively the output of the radio and the antenna's input resistance or impedance to be identical. This thing actually has a tuner in it, which will correct for that. So modern radios have that. If you have an older radio like,
Icon 706.
706, yeah. Some of the older radios don't have that, but you can get external ones that will correct for you. But if you cut this and you use something like this, which is an antenna analyzer, which tells you, is this cut right? and it hooks right in the top of that thing. It can actually tell you where the center point for 1-to-1 is, as you just literally it tells you on screen what the frequency is. You sweep through it and it goes, oh, the center point is like dead center of the band, where's where you want it. And, or if it's 10 meter, you want it in the dead center of the 10 meter voice band. And those are really, really handy to have. I picked this one up for $50, by the way, at date. So, and it was used. The battery connector was broke, but guess what? It works on power. Easy thing. And of course, modern radios will also tell you what the actual resistance of the antenna, if it's properly set up. Like that radio will tell you that. That's in case you're curious, that's a Yaesu FT991A, which is their current really nice one. Okay, so this is a basic dipole antenna. So for making a dipole for 20 meters, again, 468, which is the overall length. 468 divided by frequency, so 468 divided by 14.3 gives you feet of how long the actual antenna is. Divide that in half, that's one side, the other side. You can do it with 18 or 12 gauge wire. For example, about 5 years ago I bought this thing, wire here for like $5, which is probably like $300 now because of inflation. Everything's great, but this wire is, I think this is like 18 gauge. It's a little thin, but if you're only building it for like 50 watts, it's fine. You don't need this giant stuff. If you're going to leave it up for a while, though, you really want to use antenna wire designed to be outside. And you can buy that from any wire vendor, honestly. And then you'll need insulators. Like I said, you can buy these, they're dog bone insulators, or you can actually just simply make them out of PVC pipe, which I have done many times. And honestly, that's actually on this one. I'll show you that here, and then coax. So you want RG58, 8X, any one of those. It's 50 ohm coax, which is the point where that is the resistance that the radio wants to see, the coax wants to see, and that's what your antenna should be basically set to. And then you just assemble it. It's certainly hard again. 2 million laptops. Okay, another antenna for 2 meters, which I have one. Oops. There's a lot of coffee over. Everything is stacked on top of everything. So this is a J-Bowl antenna. It literally is what it looks like. This is for 2 meters. So this is for the 2 meter amateur radio band. And this antenna does reasonably well. And it's literally made out of copper pipe I bought from Lowe's. And then some coax I had sitting around. So these are actually really, really fun to make. They're also really easy to make. It does require a blowtorch or a big soldering iron, so obviously more fire is always good. Fire's fun. And ignore this, I didn't calculate right. This was my test one. I actually made 2 of these. I made one of these for me to see if I could do it. And then I made another one actually for a video. And that's much prettier. And I think Justin has that. He does, okay. So this antenna is actually really in the way. What's that? So the bottom part of this antenna can literally, from here to here is ground. Literally hold it like this if you wanted to, or just sit it down in something. So if you have like mast pipe, this could literally just sit right in the mast pipe. And the length of this can be 30 feet. It doesn't really matter because this is the ground point, because where the U is, there is where that's the conductive piece of it. Everything below that is 0. The only thing is, if you're going to do it, you want to make sure that you clamp it onto something if you can, just so you don't tap this part here to ground, because this is your driven element effectively. So these are, like I said, these are extremely easy to make. And I'm literally, this one's actually, the conductors are actually held on there with zip ties. But these antennas give you about, I want to say, about 4 or 5 dB gain. They're a little bit more than a dipole would give you. I want to say they're about the same as you get off like a mobile 5/8 wave antenna, maybe a little bit higher. This is actually the design that this is. I actually used this to build that back in the day. Sorry, you're talking. Don't shut up. So the way they've done this here is they've got some mass pipe coming up, and they just used hose clamps to hold that on their image. But the neat thing is this design can be made. I actually made one of these for 6 using this exact same thing. And of course, mind you, instead of roughly 4 foot tall, it was about 12 or 14 foot tall. And these can be scaled up and scaled down really, really well. Really, realistically, I've seen one for 10 that was almost absurd because I want to say that the actual tall element here was above 40 feet tall, which is a bit ridiculous. But you could build one in that variation using a tower as the driven element. So you can use it like literally like a TV tower, and then you come off with the stub. The stub here, this stub is actually quarter wave length. So the stub on a 10 meter, for example, would be about 8 feet. Well, so once this is built, you adjust where the feed point is. It's where your connection points are for your coax. That adjusts your SWR. That's where something like this comes in real handy because this doesn't put out any power enough to hurt you. You can actually literally hold it while it's on. And then you just, the way I would recommend doing that is to slide it, to use like zip ties for example, slide that up and down to where you get to your 0 or 101 SWR point, and then mark it with like just a Sharpie for example, and then disassemble it, go back and actually solder that connection on. This was a test one, I never got to solder it, but at that point then, it's good and solid. Also, if you're going to leave these outside, hit this with lacquer, or it'll like corrode. Or you can actually take this and put this whole thing inside like PVC pipe and seal it up if you want to. That actually works too. I have seen this made with like 4-gauge wire put inside of PVC pipe for the reason of, to do one avoid corrosion. But for 2 meters, these are great. This is basically an omni antenna. It's not a perfect sphere or round coming off of it because of the way it's got, but it is really close. It's got one notch on it, but it is really, really thin. And odds are you've never actually hit that. If you look at this thing as a donut looking down at it, there's a slight notch here. But again, it's like really thin, so you can just move it a little bit. Put it to a spot that there's nothing at, you don't really care about. So these are actually kind of fun. I love J-pole antennas myself. I've used these, and this is the 6th one I've built. So there's really funny thing too. So think this size with these numbers in 440, the spacing for everything perfectly fits ladder line. I've seen a 441 version of this using ladder line as the actual conductive elements, and then they tapped off of the coax, and it worked perfectly. So, yeah. The biggest one I've made, though, was on 6, and I used it for more than 10 years. And actually, I just need to take that because I forgot to lacquer it because it was stupid. I need to take it down and sand it there and then lacquer it. But these are great antennas. If you don't want to have to pay for like a base antenna, but you have access to this stuff, perfect. However, one thing you do want to remember, don't use acid core solder, so don't use like plumbing solder, use electrical solder. And the bigger stuff works a bit better than the smaller, because you just wind up using a lot of the smaller stuff. Like there's a guy over here who has like a really thick solder that works a bit better. You still kind of have to heat it up with a torch, but you just heat it up, pull the torch away, and it just flows right through there. You also will definitely want the caps that you can actually put another slide on for that. Yeah. So, there you go, Tim. I found a good use for your keyboard. So this thing is actually made with half-inch copper pipe. It takes approximately one piece of 10-foot pipe, 3 end caps, 1 90-degree elbow, and 1 T. And that's it. And then you need to have a way to cut it. Little spiral where you spin around cutters work great. We'll need RG. In this case, I use RG58. It just worked easier. You do have to make a coil at the bottom of this thing. I think it's 5 turns. I have a link to where to build this if you want to do that, by the way. And you just coil it up and it says make a coil roughly this big, for about 6 inches diameter, zip tied together, and that's the ballon that's in line to correct for slight impedance issues. And you solder hose pipe. Or zip ties. Like I said, if you're doing this for a weekend, and you're just going to use it for like a couple days, zip ties hold just fine. You get the really big ones, they hold great. And if you want to look at this after we're done, please come up. I don't mind showing you at all. Another thing you could build is a multi-band dipole, or fan dipole. These are really neat because basically you've got 4 bands here. You've got, in this case, they have an 80, 40, 20, 10 meter. And what you do is you wind up cutting these, so you wind up going from biggest to littlest when you're actually adjusting your antenna with an analyzer. Mainly because the really low band, the lower bands or longer wire, are less susceptible to change for just minor adjustments. Yep. Okay, yeah, VE testing is about to commence in the building next to us over here. If you're trying to get if you're trying to get tested for amateur radio, the VE testing starts in 5 minutes? 4, 3. It starts now. So if you're trying to get your test, go to the VE testing in the building next to us through the doors over there. You're welcome. Okay. Fundamentally, this is built the same way a standard single band dipole is made, just have extra pieces. I've also found a really good way to hack for this piece here, which is, like you're just effectively hanging down, is to use PVC pipe with holes drilled in it, and that's where you feed your connections through it. It keeps everything spaced right. And this is another one that's actually, it gets big because the length of this, the full length of this is 120 feet. And it goes like 120, effectively divides in half, 65, 35. And that's actually really fun one to build too. It's also very, very simple, and it can be built in a day for like a weekend if you're doing a contest. Nice antenna for multi-band. It takes a little bit to get it tuned, but it's not hard. I want to say the last time I built one of these, but I couldn't find it. I tried to find it and bring it with me so I can show you. But it took me about 3 hours to build it and get it tuned. And it's not too bad. It's a decent antenna. Again, it's only dipole, so you're not running like high gain, but you're certainly going to get about 3 dBi out of it, or 0 dBd. Yeah, because it is so 0. And everything's measured in decibels. If you don't know what that actually means, I can explain that to you a little bit later. But you'll see those numbers a lot, like, so many, and they measure it 2 different ways, which I think is really wrong, but they measure it dBi and dBd. dBi is an etherical antenna, basically it doesn't exist, it's a theoretical sphere. So a dipole gives you 3 dBi, or the more realistic is dBd, or decibels over a dipole, how much more gain does it have. So if you're using a dipole, obviously it's going to give you 0, because it's the exact same thing. So, but most everything should be measured in dBd. You will see some people cheat, especially when it comes to the antennas for your HT. They're like, oh yeah, it's like a 6 dBi. And you're like, that should be 3 dB. I want to say this one's actually a 3 dBi antenna on this. It's older now. But... Okay, so a few things you're going to have for the fan dipole. Obviously, a lot of wire. This is where you go find someone who's got a lot of extra wire sitting around. Because you're going to need a lot of it. To the tune of about 400 feet, I think, total. Insulators, a lot of those too. Like I said, the best way to do this though that I've seen is the 2 end pieces probably could use dog bones, but the other ones use PVC pipe because you can space it. You can just cut a piece of pipe a couple feet, just drill a hole through, and everything just feeds through, and it keeps it separated right, and coax and then rope. So I found this rope, just little plug for whoever made this stuff, but this type of rope here is like grabs itself really, really well. It's like shoestring. It's awesome shoestring material. And I've had this stuff outside for a couple of years and never break. So it's nice because you got to start thinking about that. Because like me, when I put up, so for one of the videos that some friends of mine and I did, we built a G5RV, which is a variation on a dipole, and it's still up. And I built it 3 years ago, right before COVID. So, and it's still up right now. It's not expensive though, but it really works in kind of a funny way. So each coil going out actually stops. So 10 meters goes out just fine until it hits this, which effectively from it looks like a break in the wire. And then to the next and the next and the next. Now, tuning this is probably the most complicated, ridiculous thing I've ever had to do. Because you have to tune from going out to in, of course, and then effectively you have to desolder, trim, resolder back. It's a pain. But it's not horrid, but it is a pain. Building the traps, though, is really neat, because it actually uses coax wrapped around a pipe and then connected to itself, which I believe I have a slide for that. So this is what a trap looks like. That's effectively what that is. So you've got coax wrapped around, and you literally tie the center conductor to one side, the insulator to the other, but it ties together in the center, and that's how those are actually made. And what its job is to act as an electrical brake in the wire above or below. As the frequency starts going up, it acts more and more as a big resistor in line. So when you go back to this, effectively 10 meters, 28 megahertz, effectively ends here because the resistance goes really, really high. And then 15 meters there, and 20 and 40 and such. These can be made, if you want to take the time, it is possible to make an antenna that literally covers pretty much the entire HF bands doing this. It's kind of a problem because you're going to have like 30 of these things going out each side. But it is actually really neat to build one. Like I said, your biggest headache is the trap design. But what I did is I built all my traps and then went and started working on the actual length of wire needed to go between each section. And this, of course, you're going to need the traps on these RG58 coax. So it's at least as cheap coax or cheaper coax. Oh, by the way, a cheap place to find coax, if someone has an old thin net network, like computer network from like the late 80s, which is all coax and no one wants this, they usually just abandon it. If you can find someone who's doing remodeling of an older building, as they're going in to tear out stuff, see if they're finding that. Because they'll probably just be like, here's a pile of it. We're going to throw it in the trash or the recycle bin. Because that's what that was. And that's actually where this piece of coax came from. Is we were getting rid of the whole network. Realistically, I wouldn't push it past 100. There are specs for it. I don't know exactly, but I would never push it past 100. If you're going to be running like high power, the trap dipole is probably not what you're going to want to run because the traps have to be made a very specific way and size.
The traps vary based on which frequency you're
yes.
Walking, right?
So if you look at this, everything from that. I don't know why I didn't cut this. But if you look at this, well, here. Give you an example. So the way it is that, yeah, the diameter of the actual pipe you're using, and then the amount of windings on each change. There is a formula for that. There's absolutely a formula for that. So you can look at trap dipole design, and it will tell you, here's how to make the traps, here's how to make the length, and all this kind of stuff. And like I said, Google's your friend. And that's exactly what I did. I literally Googled it. The bigger one's 2-inch PVC pipe, and it goes down to like 1 inch from there. Yeah, this antenna, I did take on my honeymoon, which you should feel sorry. There's actually me, which is really hard to see on the screen, but the dipole is there. Yeah, you should feel sorry for my wife. But as for which is the best antenna, depends on what you're wanting to do. Obviously, if you're at 2 meters, you could use a dipole. You can make a dipole, same exact concept. Just use that number, you pop in the frequency, and you come up with roughly 19¼ inches per side. For 2 meters, it'll work. Typically, those are horizontal. Now, if you're working sideband for distance, that actually works better. But for most people, like in 2 meters, you're talking locally, you're using HD to talk to a repeater. J-poles work great for that kind of stuff. Beautifully well. For HF, I said I use a variation. I use the G5RV, which is actually that. This is an offset G5RV, but the one I actually have at home is a standard G5RV I built. It's back there, 102 feet. So there's some other options, though. Of course, you can buy an antenna. I bought this one at Bloomington 2 years ago, and it's an end-fed antenna. And then I actually made this for one of our videos, and it actually works. This is a random wire antenna. That's the other option you could probably do if you wanted to. If you have a good tuner, is just a random wire antenna. So you literally just take a wire from point A to point B, tap on a coax to it, use a tuner, and get it down. Those vary depending on length and a few other things as to how good they are going to work, but they're really, really cheap and very, very quick. So that's the name of this particular thing is it cheap? Is it quick? Can we get it done? Yeah. So something like this, weekend project. Definitely if you like building stuff, try it. Google it, try it, pick up stuff, just do it, because it's one of those things that so many people are just like, well, I've got to buy this big antenna and I got to buy all this kind of stuff. No. part of the actual, I don't know, sport, but part of the whole concept of amateur radio is to experiment with stuff. Dipole antennas and similar concepts are very, very cheap to build. They're very kind of fun to actually do this stuff. You can pick up the testicles in second hand for nothing. $50 for that thing. It's like a $300 meter if you want to buy it. Look around. There's probably a couple around here. It happens. But don't be afraid to play with this stuff. It's definitely something to do. And you should enjoy it. I mean, if you're not enjoying this, you're doing it wrong.
Thanks for hanging out with us here on 3 Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.